question is from GATE 2023 from the topic complex analysis. They have given T a open unit disk like this, and they have said that f is analytic function on D. Now they have given fz like this summation a n z to the power n, and they give a0 and a1 is 1 and an is 1 by 2 to the power 2n for n greater than equal to 2. Now they have given two statement p and q. We have to verify this two statement. Now p said that f is 1 1 and q said that if e is this, now then image of f it will be what, closed or not. Okay, so let's see quickly how we can do statement p. So to verify statement p, we have to verify f is 1 or not, right? So if this is our f, we can write f like this, 1 plus z plus summation this. Look, I write here summation 1 by 4 to the power n, right? Because an is what, 1 by 2 to the power 2n. So 1 by 2 to the power 2n can be written as 1 by 4 to the power n also. So I write it here. The reason is very clear. Just now you will understand why I write this. Look, if this is your f set, now you know, it isn't it looks like summation z to the power n. Like if I write it at summation z by 4 to the power n, then can you do you remember any rule like this, summation z to the power n, right? See this, summation z to the power n is what, 1 by 1 minus z, right? Where n is 0 to infinity, then summation n equal to 0 to infinity z to the power n is what, 1 by 1 minus z. But when mod z is less than 1, right? So here our term is what, z by 4 to the power n. So can I write z by 4 to the power n as 1 by 1 minus z, 1 by 1 minus z by 4? Yes, we can write, but when z by 4 is less than 1, right? But is it here z by 4 is less than 1? They have given f is analytic when mod z is less than 1. Okay, so from here we can't write that summation z by 4 to the power n will be like this, 1 by 1 minus z by 4. But can we make it? Look, they have given an in this form. If an is this form, then what is the radius of convergence of f? The radius of convergence of f will be this, right? So if this is your an, then Cauchy-Riemann says that radius of convergence you can compute by this rule, that 1 by r will be limit supremum an whole power 1 by n. So if this is your an, 1 by 2 to the power 2n whole power 1 by n will be 1 by 2 square, that means 1 by 4, and from here you will get r is equal to 4. That means your radius of convergence is 4. That means when mod z is less than 4, then f is analytic. Okay, so now we got that mod z less than 4, then f is analytic. That means when z by 4 is less than 1, then f is analytic, right? So now this z by 4 to the power n, summation z by 4 to the power n, we can write in this form, that 1 by 1 minus z. Okay, now look, but here the limit was where? The limit was from n equal to 0 to infinity summation z to the power n, right? But here it is n is equal to 2 to infinity. So to make it n is equal to 0 to infinity, if I make it 0 to infinity, then which term we will add? We will add, if n is equal to 0, then this will be 1 by 4 to the power 0. Z to the power 0 is 1, that means at 1 only. And when n is equal to 1, we will add 1 by 4 into 1 by 4 to the power 1 into z to the power 1, that means 1 by 4z, 1 by 4 into z. So if I add this, we have to subtract this term, so we subtract this here, minus 1 plus z by 4. So now I write this term as this, summation z by 4, so sorry, summation z by 4 to the power n. Okay, now if I write this like this, so I calculate these two terms. So here minus 1 plus 1 got cancelled, and z minus z by 4 is 3z by 4. Now this summation z by 4 to the power n, I can write it as 1 by 1 minus z by 4, because our f is analytic when z by 4 is less than 1. Mod of z by 4 is less than 1, right? So if I can write this, then it will be my this form, and I can simplify fz like this. This will be my fz, 3z by 4 plus 4 by 4 minus z. Now I have to check if it's 1 or not. So to check this, I can you can take fz1 equal to fz2, and from there z1 equal to z2. But for quick, I will derive this function. I will make the derivative of this function. Okay, if this f z, then f dash z will be what? 3 by 4 plus 4 by 4 minus z whole square. Now look, where we have to check? We have to check in the neighborhood of z naught, and z naught is what? Z naught is a point of d, and d is what? D is open unit disk, right? That means mod z is less than 1. So if mod z is less than 1, 4 minus z is what? 4 minus z is less than 3. That means it is positive time, right? So 3 by 4 is positive, this time is positive. That means the whole term is positive. So f dash z is positive. So if f dash z is positive, that means what? F is strictly increasing, and f is strictly increasing means what? F is 1 1. So hence option P is true. Now we have to check option Q. Q says that E have given like this, mod z less or equal to half. So do you know Hahn-Borel theorem? It says a closed and bounded set is compact, right? Closed and bounded region. So here this is mod z less or equal to half. So hence it is compact, right? Hahn-Borel theorem actually we can apply when our dimension is finite. So Q is finite dimensional, right? In Euclidean space, two dimensional. So this is a compact set, mod z less or equal to half, and F is what? F is analytic, right? Analytic on where? Analytic on D in the unit disk, and E is a disk of half radius, right? So E is actually subset of a D. So if F is analytic on D, then F is analytic on E also, and analytic means it is continuous also, right? So you know a theorem that if a function is continuous, then continuous function maps compact set to compact set, right? So E is your compact, then compact image of the compact set f of E will be compact, right? Compact means it's closed and bounded, so of course it will be closed, right? And even bounded also. So they have said f of E is closed or not. So your answer is right. So f of E is closed. Okay. So hence both the option is true. That means which option will be your? P is true. That means option A. Q is true. That means option is B. Okay. I hope you understand the solution. Thanks.